Hello, this is Bobby with Coppell TV Repair with a video today of troubleshooting Panasonic TC-P55ST30 and probably a few others that use the same boards. Now this is just the back cover, which is on a different table here. I'm going to move where I actually have a TV open. That's how it looks from the back. I'm not going to tell you how to open it. Just lay it down. I don't remember. Some of them you can actually take the back cover off. I mean, some models you can take the back cover while it's still standing. On others you can't. I have another Panasonic here that's different. On this one, I'm pretty sure the back cover can be taken without taking the stand off. For this one, which is the one that I showed you, 55ST30, you may have to lay down as with it and unscrew everything on the back in order to get to the unit. As I said, it blinks 7 times, and you may find more details if you open on internet. This is a TV that came here yesterday. This is exactly the same TV that we actually use for testing. This is a customer's TV, and before I start with anything else, one thing that I would like to tell you is when you get a TV that is this dirty, has that much dust and dirt inside, the first thing that you should do is open it, take it outside, and get a sucker, or what we use is cans of air. Just dust it off. Dusting off the speakers doesn't make a lot of difference, but the power supply and the 2 sustain boards, when we were opening that should have been done on the spot. My guess is the TV was brought without the stand, and we are going to do it, and so should you, even as a first step, even if you don't know if the TV is working. It's an example of something that should have been done right away. Now let's go back to the 7 blinks. If you have read on internet, that is usually the SC board, which is upside down facing from here, but it is TNPA5351, or as you might have found, it's one of the buffer boards. Internet says it's usually the upper. What prompted me to make this video was that we found a problem on the sustain board, and we actually fixed it before I could make that video. I wish I had made it earlier. And after we did, the problem was still there, and it turned out that one of the buffer boards was bad. And it turned out it's not the one that is usually bad, which is the upper. In our case, it was the bottom. And actually it still is, and at that point I decided to make a video. I'm going to show you a few things about how to measure and how to find out stuff. Troubleshooting plasmas is very similar, with a few major ifs. I will go along with the simple troubleshooting here, and a lot of what I'm going to say is common for all troubleshooting all plasmas, but there are a few key points where, depending on, things may be different. For example, on many older style plasma TVs, you can just disconnect the power cable to the sustain board, and if you turn it on and the TV stays on, as opposed to trying to come on and then shuts off with whatever number of blinks or whatever other code, then you know that this is preventing the TV from coming up. Panasonic for years have been having feedbacks from the boards through here, and if that board is not responding properly to the main board over there, the TV would still shut off. In other words, the elimination by disconnecting from power doesn't work so well. Samsung and LG built between 2006 and I would say pretty high. The first Samsung that I saw do something like that was made maybe 2012. So, you know, pretty much all Samsungs that I've seen built in those years, and I have seen quite a few, you can eliminate. On Panasonics, you can't, but I guess there are always exceptions. So that's one thing to watch for. You can't just disconnect and say this works, this doesn't. Now, on any sustain board, and like on this one, what usually goes bad is power switching transistors that are being used to form the voltage that electrifies the small cells in the plasma panel with very high or very low voltage. There are a number of voltages that are being supplied, and just think of those as something that at some point when they close, just opening closing switches, when they close, they output high voltage to the plasma buffer boards. Shortly later, it needs to be lowered down, and that circuit is open, and another one is closed, which provides different voltage, and it actually walks up from, let's say, up to 240, 250, down to minus 120. They work very hard, those transistors and switches, and they overheat over time if they're misdesigned or weaker ones are used, or just from the thermal expansion and shrinking is my theory. They don't just overheat while working. What actually happens is something different. But staying to the focus here, there are two types of components you will often see, power components, on all those sustain boards. One is a transistor, and the other one is a diode. A transistor has 3 legs, and a diode has 2, but sometimes diodes are made in the same package as transistors, and they're actually made to have also 3 legs. One is on the bottom that they are laying on, and the other 2 are down here. For transistors, those 2 are different. For diodes used in power components, they can be the same. The reason I explain all that is because what I'm going to tell in a second does depend on whether a diode is being tested or a transistor. Diodes can be most easily told by simply looking at the label next to the component. In this case, this says D401. That is a diode. Next to it, same package component says something different. It says Q401. Q is a common label for a transistor, and the biggest difference, and the reason this is important, and the reason I'm telling you this, is in diodes, those 2 electrodes are usually the same unless there are 2 separate diodes built into this, which is often the case. But even then, electrically, the 2 of them are the same thing. So if you try to measure resistance, which is the way how we find burned components, shorted components on a board, is we measure for resistance. If there is no resistance, then the device is shorted and burned, and that's a bad thing. How do we measure resistance? You can find tons of videos of that. That's classic fluke. You turn it to a dial with a sign of a diode. You can achieve the same with any resistance meter section. This is actually better. And you just touch the 2 probes. That's a short. There is, electricity is flowing freely from one cable to the other. The fluke is beeping. A lot of devices will have a sign here for speaker, like this one. And you may use that. The fluke is very nicely done. Usually test is done in diode mode, not necessarily, but usually, for a number of good reasons that I'm not going to be talking about now. And this is how we search for shorts. So, if we are measuring a diode here, those 2 will be shorted. You can hear the device. It says 0 there. But that's normal. That component is not bad. The way you test diodes is you got to test one of those 2 and the opposite end. And what you're going to see is something that is usually not necessarily infinite, like an open probe. Like I'm not touching them at all. See, I'm removing that one. It's infinite in one direction. That's called the direction when you change the polarity and you try, and usually has something like 0 point something. It can vary. It depends on the diode, on the schematic, on a number of things, on the device that you're using to measure. It can vary anywhere between 0.17 to 0.65, 70. Again, that's different. But there is a huge difference between the two. You see, in one direction it's almost infinite, or very, very high. Sometimes it can be bypassed with other things. This is a good diode. Now a transistor has 3 outlets to test. That's one of them. There's another one. I'm sorry. Should have been doing that with a helper, but the helper went away. And what you do is you want to test as many of those as you can, even though some of them are in parallel. In other words, whatever reading you're going to find here, they're going to be the same here and here, because those 3 are connected and working in parallel. This is done so that the resulting device is one that has triple the current capacity of a single one. A lot of them are done that way on that board, and it's actually easy to see how. What you do is you're going through those searching for a short, for a beeping, or something that is a very low read. Sometimes they don't short out totally. They just get a very low, like ohms reading. For good or bad, for bad for the sake of showing this off, I have only shown, we have both of those boards repaired. The reason I brought another one is to show you what is under those heat sinks that Panasonic has sealed with silicone, and here we have taken out for whatever reason, or here. This is the same board up there without the heatsink, and you can see that it has the same devices. What you will end up doing is I recommend against taking the whole board out. You want to just stick it sideways like that, the probe,